for this quarter. Okay, so we're going to review about radical function or the rational function, wherein we're going to describe how the radical function translated from its parent function. Okay, so radical function is a function whose rule is a radical expression, wherein the parent function is y equals the square root of x, or f of x equal to the square root of x. That is the parent radical function that we have. Okay. So how are we going to graph radical function? The same when we are solving for our quadratic function, nonlinear function, and the other type of function that we have. We need to solve for the value of y, proceeding that we have the value of x. So you're just going to substitute the given value of x in your radical function given. For example, we have f of x, the square root of x minus 3. Given that the value of x is equal to 3, so substitute the given value of x, which is 3, in our radical function. So we have 3 minus 3. So square root of 0 is equal to 0. And we have the coordinate of our radical function, which is 3 and 0. So the same process of how we get the input and the coordinates of our quadratic function and the nonlinear function. That is the same on how you're going to find the coordinates and the output of your radical function. Just need to substitute the given value of your x. To describe the translation that happens to our radical function, we have the standard form of the radical function, which is f of x equal to a square root of 1 over v times the quantity of x minus h plus k. That is the standard form of our radical function, wherein we look at the h and the k, the A and the B, to describe the translation that happened to our radical function. When we have an H that describe if you're going to have a horizontal translation, and if you have a vertic that is described for the vertical translation, how many unit that translation happen for your radical function vertically, and for your H horizontally. And for A, if you have a positive value for A, the description of the translation that happened for the radical function, it's vertically stretch or compression factor. If you have a negative A, the, the description or the translation that happened to the radical function is a reflection across the x-axis. And when we have a positive B, it will have a horizontal stretch or a compression factor. If we have a negative B, the translation happened to your radical function is a reflection across the y-axis. So those are the things that we need to remember to describe the translation that happened between the parent function to the radical function that is given. So we have also this table. For example, we're going to describe the transformation of the graph of the function f of x or g of x equal to negative square root of x minus 4. So looking at the function that we have, This is our h, 4 is our h, and negative is our a. So looking at the description or the sign of our h and a, what description we can have the transformation happen to our function g of x equal to negative square root of x minus 4. Kapag meron tayong negative a, what description we can have? We have negative a. Is it compression or reflection to our x-axis?
Reflection across the x-axis.
That's correct. We will be having a reflection across the x-axis. Based on the symbol or the value of our a. Since a is negative, the description or the transformation happened to our a, it's reflection across the x-axis. What about the h? How many units will the transformation of our function go horizontally? Right? How many units to the right? 4. We have 4 units based on our h. It will go to our right 4 units to the right. Since we have a 4 for the value of h. The value of our h is 4. So that is the description that we can use to describe the transformation happen to our radical function g of x equals negative the square root of x minus 4. Since we don't have a, we will not be having a vertical or it's moved upward or downward of our parent function. So we can only describe this radical function. It reflected across the x-axis and it moves to the right 4 units. So let's have another example describing the transformation happened to our radical function. For example, we have the radical function g of x equals the square root of negative x plus 3. So that is the quadratical function that we have. Since we don't have a, so we no need to describe the transformation that happened to a. The things that we have in our radical function is b. Describe the b that happened or transformation that happened to your b and your k. 3 is our k based from the standard form of our radical function. So looking at the b, we have negative. Negative b is the one that we have from our radical function. Since we have negative, what is the description if we have a negative b? Compression or reflected? Reflect. Will it be saan mag-reflect? X-axis or y-axis?
That's the y-axis.
Y-axis. So it will reflect to our y-axis since we have a negative b reflected to y-axis. Since we don't have h in our radical function and the things that we have is our k. How many units did our radical function move vertically? Is it upward or downward? Since we have positive, up means move 3 units upward. Since it's positive, we have positive 3 for our value of k. So that is the description that we can have to our radical function. Reflected across the y-axis and it moved 3 units upward. Yes, Gabby.
Where will the quiz take place? Quizzes?
It will take place in your Google Docs.
Okay. Will will there be things like describe the thingamajig transformation?
Yes.
Okay. On
Okay, so that's how we describe radical function. So for example, we have this radical function, which is g of x equals to negative 3, the square root of x minus 1. So our a is negative 3. This is our a. And this is our k. Negative 1 is our k. So we don't have the value for b and the value for h. So using the description for a, if it's negative, the description of our radical function is what?
Reflection to y at the x-axis.
Reflection to our x-axis. And since we have negative 1 for our k, upward or downward?
Downward.
Downward. It moved 1 unit downward from our parent radical function. So that's how we describe our radical function. Okay na, in describing radical function. Okay na tayo. Vertical stretch. Yeah, it's still vertical stretch kasi meron tayong positive b for the x. Positive 1. So it's vertical stretch reflected to the x-axis and 1 unit downward. So that is the description that we can have for this radical function. So let's proceed with the other topic that we have discussed. So we're done describing the transformation happened to our radical function. Let's proceed in solving and graphing radical inequalities. So let's proceed in graphing the inequality radical function that we have. For example, we have the radical inequality function, which is y greater than 2 square root of x minus 3. So that is the one that we're going to solve. Given the value for the x, the same on how we solve radical function, you just need to substitute the given value of your x to our inequality function. So 2, for example, the first value of our x is 0. So 2, the square root of 0 minus 3, which is equal to 2 times 0 minus 3. So we have the value for y, which is equal to negative 3. That's the first value of our y. That's how we solve for the value of y in our inequality radical function. To graph radical inequality function, if the sign of inequality is greater than and less than, you're going to use dash line or a broken line to graph our inequality radical function. If the sign of inequality is dash, greater than or less than, you're going to use the broken line or the dashed line. For example, this radical inequality function that we have, which is y greater than 2 square root of x minus 3. So once we graph, since we have already the value for our x and y, the graph of our radical function will look like this. Because since it's greater than, the shaded part of your graph is the upper part of your dash line. That means this part is the set of solution for your radical inequality. So since we have the first value of your 0, x and y is 0 and negative 3, so that is the starting point of your graph. And all the points in this broken line is not part of the solution of your radical inequality. But if the graph uses a darker line or not a broken line, that means all the points on that line is part of the solution of your radical inequality. So to check, for example, we're going to check if we are correct in solving if the points in this boundary, the one that we have shaded, is really the set of solution of our inequality radical function. For example, we're going to use this point from the shaded part of the graph in our radical function. So the coordinate of this point is positive 2 and positive 2. So let's check if we are correct in shading the set of solution from our inequality radical function. Our radical function is y greater than 2 square root of x minus 3. So the value of y that we have based on points that we're going to check is 2 greater than 2 square root of 2, since that's the value of x from the coordinate, minus 3. So 2 greater than, what is the square root of 2? 1.4. 1.4. So 2 times 1.4 minus 3. So 2 greater than 2.8 minus 3. So 2 is greater than negative. Zero point 2. So the statement is correct that 2 is greater than negative 0.22. That means this graph of our inequality radical function is correct wherein we shade the upper part of our graph since it's greater than. So kung less than, if the sign is less than, the shaded part will be below or at the bottom of your graph. Okay? That's how we graph for the radical inequality function. Question about, yes po. Greater or equal to. What will be the graph if the sign is greater than or equal to? Is that what you're asking? The graph, if the sign of inequality is greater than or equal to, less than or equal to, is not a broken line. It will be a complete or a solid line. That means all the points from this line is part of the solution of your radical function. You're going to check, for example, the points here, since the sign is greater than or less than or equal to, that means that points it is part as the set of the solution of your radical inequality function. It's the difference between your sign greater than or less than, since the points on that line is not included as the solution. Okay, any more question about radical inequality function? Okay na, with the radical inequality function. Let's continue with the other topic that we have. Okay, so let's proceed with the logarithmic function, the last topic that we have discussed for the first quarter, wherein we change or convert the logarithmic function from its logarithmic form into exponential form. So the only thing that we're changing, since logarithmic has its parts, which is the base, the argument, and the answer. So to change the logarithmic form from logarithmic into exponential, just change the argument and the exponent. For example, we have the logarithmic 2, 3 equals to 5. So to change the logarithmic into exponential, we're only going to change the argument and the answer. So what will be the exponential form of this logarithmic function that we have? What is the exponential form? 2
To the fifth power.
to
Two equals right off the bat, ladies and gentlemen.
Equals
Let's all give a
three.
round of applause.
equals to 3. So the base will still remain as the base of your exponential form. The only thing that is kept interchanged is your argument and your answer. So when we write from logarithmic into exponential, the argument will become the answer of your exponential form, and the answer from your logarithmic form will be the exponent of your exponential form. So that is how we convert from logarithmic into exponential. And to change exponential to logarithmic, it's just vice versa of what you did in changing logarithmic to exponential. For example, we have the exponential form 5 squared equals to 25. For example, that is the exponential form that we have. So if we're going to write this exponential form into logarithmic, we will be having logarithmic 5 25 equals 2. So that's how we rewrite the logarithmic into exponential form. Okay, now with logarithmic function. So what else do we have here? So let's proceed with the properties of logarithm. We have the properties of logarithm wherein it's just the rule of exponent. We have the product rule, the quotient rule, and the power rule. So let's start with the product rule. So when we have product rule, or to expand, when we say properties of logarithmic, that means expanding and condensing the logarithmic function that we have. For example, we have this logarithmic function. Example, logarithmic function 2 5x. So for example, we have logarithmic 5x and we're going to expand this logarithmic function that we have. So since we have 5x as our argument in the logarithmic function, the rule that is being used in 5x is the product rule. Diba? When the product rule in the law of exponent, we add the exponent. So the same concept you're going to use in your product rule for the logarithmic function. So we will be having, or the expanded form of logarithmic 2 5x is logarithmic 2 5 plus logarithmic 2x. So that is for product rule. And for quotient rule, the same with the rule of exponent. When we are dividing, we subtract the exponent. So the same concept apply to our logarithmic function. For example, we have logarithmic 3 3x 3 over 5. So for example, that is the logarithmic function that we have. So since the operation is division, and that's apply our quotient rule, so we're going to subtract this two argument or two logarithmic function that we have. We will be having logarithmic 3 minus logarithmic 5. That is for quotient rule. And for power rule, the same when we are having the rule for our exponent, which is power rule, wherein we multiply the exponent when we have the power rule for exponent. For example, we have logarithmic 2 x squared. For example, that is our logarithmic function. So to expand using the power rule, we will be having 2, the exponent of your logarithmic function, and then logarithmic 2x. So that's how we expand our logarithmic function. Okay na for expanding. So let's proceed with condensing logarithmic function. For example, we're going to condense this logarithmic function applying all the rule that we have for logarithmic function. Example, logarithmic 3x plus logarithmic 3y minus logarithmic 4. For example, that is the expanded logarithmic function, and we're going to condense this logarithmic function that we have. So let's start with this 2 logarithmic. The rule that is applied to logarithmic 3x plus logarithmic 3y is the product rule. So we're going to have logarithmic 3x times y. And then we have minus logarithmic 4. So divided by 4. So that is the condensed form of the expanded logarithmic 3x plus logarithmic 3y minus logarithmic 4. Okay na, in condensing and expanding logarithmic function?
Yes.
Yes. So we're not going to review with the operation involving functions since we just discussed it last Tuesday, and I think you still remember it. Naalala pa naman siguro yung for
Wait,
operation.
what? I actually have amnesia. What? Wait, hold on.
Wherein we use the synthetic. We use synthetic. The for operation, the adding, subtracting, multiplying, and dividing function.
When I say that I forgot, my mind. Quarantine's done this to me. Like I was a memorable man.
Wow, you're a memorable man. Sige,
I remember very.
let's have one example for the operation, for operation involving our function. Let's say we have the function f of x equals to x squared plus 2x plus 3 and the g of x which is equal to x minus 2. So let's start with the first operation, which is addition. So let's add these two functions that we have. So f and g of x. So x squared plus 2x plus 3 plus our g of x function, which is x minus 2. Diba? When we are adding and subtracting, the only thing that we can add and subtract is the terms that are the same or like terms. So since x squared doesn't have a like term, so it will remain as x squared. 2x plus x, we have 3x. And 3 minus 2 is equal to 1. So that is the sum of our two functions. Let's proceed with subtraction. Subtracting the two functions that we have. So f of g x. So x squared plus 2x plus 3 minus x minus 2. So the same concept. Subtract similar terms. So we have x squared. 2x minus x is equal to x. 3 minus negative 2 is equal to positive 5. So that is the difference between the two functions. So let's proceed with multiplying. So f and g x. So you have x squared plus 2x plus 3 times our g of x, which is x minus 2. So since we cannot use the FOIL method, we're going to use the distributive property to find the product of our two functions. So x squared times x is equal to x cubed. X times 2x is equal to 2x squared. 3 times x is equal to 3x. Negative 2 times x squared is negative 2x squared. Negative 2 times 2x is negative 4x. Negative 2 times 3 is negative 6. Combine similar terms from all the products that we have in the expression. So we have x cubed, 2x squared minus 2x squared minus 2x squared is equal to 0. So 3x minus 4x is equal to negative x minus 6. So that is the product of our two function. So let's proceed with division.
Here we go. Here we go. Ladies and gentlemen. Ladies and gentlemen, welcome
Division.
to
Using the synthetic division. So we have get the coefficient of all the terms that we have for f of x, which is 1, 2, and 3. It's the coefficient and the constant number divided by the opposite of negative 2, which is positive 2. So bring down 1. 1 times 2 is 2. 2 plus 2, which is 4. 4 times 2 is equal to 8. And 3 plus 8, which is equal to 11. So the quotient of the two functions that we have is x plus 4 remainder 11. That is the quotient for our two function f of x and g of x. Okay? Okay na for the 4 operation. Alin po? Which one? The divisor. It came from here. The opposite of your constant number.
Why am I unmuted? What? What's going on? Oh, also teacher? Asymptotes.
The asymptote. Sige. Okay na with this one for operation. Can I clear the screen? Let's proceed with the asymptote. Okay, so let's proceed with the asymptote. We have three types of asymptote, which is the vertical asymptote, the horizontal asymptote, and the oblique asymptote.
It's in the quiz, right? It's in or is it not?
Let me think if I'm going to include the asymptote. Because you
It
asked,
wasn't.
I already forgot
No.
it. I already forgot the asymptote. But can
Gabby,
you remind me
it
of
wasn't me. It was.
You know what? It was.
You remind me of the asymptote. That's why maybe I will include it. You mentioned it. So, bakit yung ulo ni Job? Kasalanan ni Gabby. Sige, let's have the vertical, the horizontal, and the oblique asymptote. So, to find the vertical asymptote of our function, sige, I will not include the asymptote. Pero kay Gabby, sa exam ni Gabby, merong asymptote. But the rest, you will not be having asymptote. Only Gabby has.
Why are you pumping your hands? Why are you all clapping? No. 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 Happy birthday. No.
Because your birthday, that's your birthday gift. You will have an exam for asymptote. It's a nice birthday gift, right? Okay. So since we are done with our review for the topics that is included with your exam next week, and Gabby, just study on your own with the asymptote. Be ready. Since your other classmates is not included, I will not review it anymore. You review it on your own. So I'm looking forward to your score, Gabby, especially in the asymptote. Especially in the asymptote question. I hope you got all correct. Dapat walang mistake doon, Gabby, ha? Sa mga asymptote question. You have 20 question about asymptote. Okay. So, since we are done, I think that will be all for today. Goodbye, everyone. See you.
Teacher,
Yes.
could you send me the PowerPoint that you used today?
Okay.
Thank you.
Me as well.
Okay.
Please.
Okay. Bye, everyone. See you tomorrow.
Okay, bye.
Be ready, Gabby. Ha? Study the asymptote, Gabby. Bye.
Happy birthday, Ma'am Celine.
Happy birthday, Ma'am Celine ka pa. Uwi.
Updated.
Dapat Gabby na. That's why we have
Okay.
to Gabby nga eh.
We're having too much fun.
Goodbye. See you tomorrow.